Hello, friends. Welcome to Science Talk. I'm your host, Jim Assa. Okay, returning to topics I've covered numerous times before, trying to bring you some new information. Polar concerns are increasing as the ice now melts ever faster. Okay, for example, the sea ice around Antarctica, it's melting. And as it melts, basically the sea ice serves as kind of a barrier preventing the land glaciers from entering the ocean. Well, you lose the sea ice and it is melting. There's really nothing to stop the Antarctic glaciers from not just going into the ocean, but accelerating their pace towards the ocean. And that's what's happening. And basically, the glacier that scientists are really anxiously observing is the Pine Island Glacier. Pine Island, Thwaites, Brunt, those are all glaciers I've discussed with you before. Thwaites is in imminent collapse, some scientists are saying, and now they're looking at the Pine Island Glacier that appears to be really accelerating. So they're basically saying that the Pine Island Glacier, with the part that can break off in of itself, that one glacier would be sufficient to raise global sea levels by half a meter, 50 centimeters. And of course, we have what's going on with the Arctic. I've been discussing this with you in considerable detail and depth as of late. And the Arctic sea ice is thinning. And it's thinning in 3 separate coastal regions that could now be happening twice as fast. Once again, we see an acceleration. We see an exponentiation. And of course, these findings are linked to the burning of the fossil fuels. That's the increase in the ratio of greenhouse gases in the atmosphere. We all know that by now. This is pretty established science. Between 2017 and 2020, the ice shelves have undergone a series of collapses and lost 1/5 of their area because the glacier has been accelerating. The glacier has been accelerating because, as I just mentioned, the sea ice is disappearing. So Ian Joffin of the University of Washington says, we may not have the luxury of waiting for slow changes on Pine Island. Things could actually go much quicker than expected. Talk about an understatement. The processes we've been studying in this region were leading to an irreversible collapse, but at a fairly measured pace. Things could be much more abrupt if we lose the rest of that ice shelf. So he and his team and colleagues, in a paper published in the journal Science Advances, that the Pine Island Glacier has already become Antarctica's biggest contributor to sea level rise. The pace of flow remained fairly steady from 2009 to 2017, but looking at data from Europe's Copernicus Sentinel satellite system, a bunch of them up there, showed an acceleration of 12% in the past 3 years. Talking about kicking it up another gear. The Pine Island Glacier contains approximately 180 trillion tons of ice, which is enough to raise global sea levels by half a meter, as I mentioned earlier. Researchers have calculated that it might take a century or more for slowly warming polar waters to thin the ice shelves to the point they can no longer keep the glacier at bay. Well, now it seems that the big player in the shelf ice collapse is the glacier itself because the flow rate's increasing. And you're losing the sea ice. So it's just literally galloping towards the ocean. The loss of Pine Island's ice shelf now looks possibly like it could occur in the next decade or two, as opposed to the melt-driven subsurface change playing out over more than 100 or more years. So it is potentially much more rapid and abrupt change. Looking to the other side of the planet, at the Arctic Ocean. British researchers used a new computer simulation to explore measurements from Euro's Cryosat-2 satellite. The scientists reported in the journal The Cryosphere that the thinning of ice in the Laptev and Kara Seas north of Siberia and the Chukchi Sea between Siberia and Alaska has increased by 70%, 98%, and 110%, respectively. 110%, that's like losing all the ice. And then some. Sea ice diminishes each summer, forms against each winter. Of course, we know that. Each successive summer reveals an ever greater loss as the ice itself thins and the area covered by ice decreases. I've been tracking this for you. You've been seeing my reports. When I look at the sea ice and the extent is declining, the multi-year ice is declining, which means the volume is declining. Hence, that's the thinning that they're referring to. I've covered this all with you. Right now, we're just actually starting to put quantitative, values on how fast things are happening. Calculations of ice thickness have always allowed for fresh winter snow, but formation of sea ice has been later every year. There's been less time for snow to accumulate. That makes a difference. The thickness of the sea ice is a sensitive indicator of the health of the Arctic. That's a statement from Robbie Mallet, University College, London. It is important as thicker ice acts as an insulating blanket, stopping the ocean from warming up the atmosphere in winter, protecting the ocean from sunshine in summer. Thinner ice is also less likely to survive the summer melt. And as you now know, I've done several very deep dive videos explaining the mechanisms for the Arctic sea ice melting away. Freezing, why it freezes later in the year, melts early in the year. Explain that to you. I've given you quantitative measurement of the extra heat content measured in terawatts, joule, zeta watts, what have you. The flow rate going, how many sphere drops. I've given you quantitative values to give you an indication of why things are heating up. Yes, we know the sunlight warms the ocean, so you got the specific heat. It takes longer to cool down and form the ice, but we now are seeing that most of the heat is the result of intrusion into the Arctic, the Atlantic side and the Pacific side, and the oceans are heating up drastically, so they're bringing in all that heat. That heat is what's melting the sea ice earlier in the year and contributes to delaying the freeze up later in the year. We see the potential from increase from like over 7 months or something like that. So, but this is to me is stunning to see what's happening in the Laptev Kara Sea. They mentioned the Barents Sea, but the heat from the Atlantic is keeping the Barents Sea pretty much ice free now. And now of course the Chukchi Sea is said to become ice free within a couple of years. But 98%, 110%. Geez, the Laptev Sea is already, the ice is disappearing on that. And of course, the Kara Sea. So it's just incredible what's going on. So we're losing, we could lose the Pine Island. That seems to be accelerating. We'll see what's going on with the Arctic Sea ice. Everything is heating up. And as you heat things up, it's going to spell trouble for the planet, because especially the rapidity of what's happening. Lose the Arctic, lose the polar regions, nothing to stop planet Earth from entering another hothouse Earth stage of its existence. And that will basically spell the doom of the human species, along with many, many other species, flora and fauna, eukaryotic, prokaryotic, multicellular, single cellular. mass extinction event. Okay, stay tuned. Thank you for your time. Okay, just a little addendum since I recorded this video. The Chukchi is doing some interesting things this winter. The ice extent is actually close to the median of the last 30 years. Not near the bottom, but near the median. It's still lower. However, the ice still formed later in the year than historical averages indicate. Now, I attribute this to, and just to be clear, no causality has been demonstrated, but my hypothesis is that the Arctic dipole, the position of its high pressure system, is influencing what happens in the Arctic, as well as the phase of the Pacific decadal oscillation is also affecting temperatures. There was some late season storms that churned up the Bering Sea and basically brought cold water to the surface, as well as impede the flow of warm Pacific oceanic waters into the Arctic Ocean. All of these coupled with La Nina is, in my opinion, is what's giving rise to the higher than what we've seen in the last few years levels of sea ice in the Chukchi. However, the rest of the Arctic Ocean is still decreasing as far as the sea ice is concerned. So just wanted to add that little addendum. Hello folks, this is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.